Hello everybody. This presentation is about the effects of drying temperature, particle size, and supplementation to improve the value of hard kernel corn for chickens. On typical poultry diets, corn can represent around 60% of the diet and contribute with 65% of the metabolizable energy in the total requirement. Due to the importance of corn in animal nutrition, corn processing factors such as drying temperature and post-grinding particle size reduction have been evaluated. It has been observed that corn starch structure can cause nutritional differences between maize varieties and after drying at high temperatures with high initial humidity. Consequently, starch and gluten proteins affect the vitreousness and kernel hardness of the grain. Our lab has confirmed that a harder kernel corn is more difficult to digest. However, the addition of a commercial amylase at a standard dose has proven to enhance corn digestibility. For that reason, the objective of this study was to evaluate the effects of corn drying temperature, particle size, and amylase supplementation on chick life performance and nutrient utilization. To carry out this experiment, a hard kernel variety of corn was dried at 35 and 120 degrees Celsius and ground fine and coarse. This corn was used in starter diets that were formulated based on Cobb 500 recommendations to feed 480 Cobb 500 slow-fatty male chicks. Diets were supplemented with 3 levels of a commercial amylase: 0, 133, and 266 grams per ton. These 3 factors created a 2 by 2 by 3 factorial arrangement with 12 treatments and 8 replicates per treatment. Body weight, feed intake, body weight gain, and feed conversion ratio were the variables analyzed on live performance, while ileal and excreta samples were collected to evaluate energy utilization and nutrient digestibility. In the results, chicks fed diets with corn dried at both temperatures and supplemented at 266 grams per ton were more efficient than those fed diets with 0 or 133 grams per ton of amylase. Also, within diets with corn, more feed intake was observed when chicks were either not supplemented or supplemented at 133 grams per ton as compared to chicks supplemented at 266 grams per ton of amylase. Similarly, particle size affected the other live performance parameters. In this case, diets containing fine hard kernel corn produce heavier chickens at 14 days and better feed conversion ratio. In nutrient utilization, all results are in dry matter. The best excreta crude protein digestibility within diets formulated with corn dried at 120 degrees was observed when 266 grams per ton of amylase was supplemented, compared to diets without supplementation. The starch digestibility was also affected by treatments. Chicks fed diets with corn dried at 35 degrees, regardless the amylase level, utilized 2.4% more starch than chicks fed diets with corn dried at 120 degrees. In hard kernel corn, the higher the drying temperature, the worse nutrient utilization. Moreover, the amylase supplementation increased in average 147.5 kilocalories the metabolizable energy retained by chicks. In conclusion, grinding to a fine particle size this corn with hard endosperm demonstrated to be a strategy to improve chicken live performance. Also, drying corn at high temperatures impaired the starch digestibility, and the amylase supplementation improved feed conversion ratio and energy utilization. Thanks to DSM for providing us with the amylase and funding used in this experiment, and the North Carolina Department of Agriculture and Consumer Services for all the arrangements in the corn planting, harvest, and processing. I hope you have obtained valuable information from this presentation.